In the first tutorial, we are going to generate a spatial correlated random field of the hydraulic conductivity parameter given the stochastic parameters, which are the mean, the variance, and the integral scales. And these fields can be utilized for groundwater flow and transport simulations. The examples files are within this folder, in the Argus Interware Examples SmartGEO Project Samples folder. So we can copy the first example file called hydrogen in a new folder in the desktop position here. At this point we can open an Argus One software, and we can open in the desktop and tutorial 1 folder the example file called hydrogen. Here, if we want to look at the project info, we have to go to piles of the project info, and we can see that the time unit selected is seconds and length unit selected is meter. In this case, the pilot points and the measurements options are not selected because we want to obtain only a spatially random correlated field without conditioning the field with direct measurements or head measurements. And by clicking on Back to Argus One project, we can start working in the SmartGEO project. We have only 3 layers called domain, density, grid. We can start filling the domain layer by selecting here the layer domain. And here we can draw the polygons which represent the area where we want to generate the hydraulic conductivity field. The polygon can be drawn by selecting this tool and by drawing polygon, and when you close the polygon you can set the density value, which represents the mean size of the cell for the grid. We can delete this polygon because we have another polygon already drawn here, which is a square 200 meters long and 200 meters high, and the density value is set equal to 8. In the grid layer we can create our numerical grid by selecting a magic wand and by clicking on a point inside the domain. At this point, since another grid was already created before, we have to click on the regrid button, but before doing this you have to remember to not check this option, because at the moment SmartGEO is not able of dealing with angles different from 0. So click on the grid and the save grid is displayed here. With the grid layer activated, we can start running SmartGEO by selecting piles, run SmartGEO. It's really important to select here the working directory where all the output files will be saved. This tutorial first is our working directory. This warning message is remembering us that we are working with an evaluation version of Argus One. And here the stochastic parameters for the generation have to be set. They are the mean of the logarithm of the hydraulic conductivity, and we can write minus 4.5. The variance of the logarithm of the hydraulic conductivity is set here and is equal to 1. And here we have to define the integral scales along the x and y direction. And in this case we can write 20 meters and 20 meters. We have to define also these bridging parameters. These 2 parameters represent the grid size. These parameters represent the size of the conditioning area utilized for generating each point of the grid, and XSP should be at least equal to 2 times the integral scale along the x direction, and YSP should be at least equal to 2 times the integral scale along the y direction. Here we have to choose the shape of the covariance function, and here we have to set the number of Monte Carlo simulations that we want to obtain. We can write 2, and here we have to set the seed number, which is a number utilized by the code for generating random values. In the Matplotlib parameter we don't have to fill anything because we are not running flow simulations for now. It's really important to save all the settings here in a TXT file, so we can load the file in a second moment and running again the same simulation. After this we can click on Run for running SmartGEO. Always with the grid layer active, we can display the results of our simulation by selecting PIES, SmartGEO post-processing, and in the working directory we can see that we have 2 output files because we are running 2 different Monte Carlo simulations. So we select the first output file. Here we have to select the parameter to visualize, and we can choose between the hydraulic conductivity or the logarithm transformation of the hydraulic conductivity. And this is our field. In the output 001 heat cond layer, there is the image of the random field, whereas in the output data layer there are the data. So the output data layer is a data layer that we can export in a matrix, and we can import them and then the same data for running other simulations. Thanks for your attention. Bye.